Okay, so here's some examples of the quotient rule. The quotient rule, it's when you have one function divided by another function, and it follows this formula. The derivative of the first, or the top, multiplied by the original of the bottom, minus the original of the top, derivative of the bottom, all over the original of the bottom squared. So doing some examples, okay, the derivative of the top, okay, that's just going to give me -4, times the original of the bottom, 2x plus 1, minus the original of the top, the derivative of the bottom, all over the bottom squared. Now you can probably do a little bit of simplifying, okay, what you have on the top. So that's going to give me -8x minus 4 minus, multiplying that by 2, so that's going to give me -6 plus 8x, and all over 2x plus 1 squared. My 8x's will cancel out, and my derivative is just going to be -10 over 2x plus 1 squared. Another example, y equals 3x over the square root of 2 minus the square root of 2 minus 4x. So first thing I'm going to do is I'm going to write out the write it out as being 2 minus 4x to the exponent of 1/2. Now this is a quotient rule. I'm dividing. I have two different functions, but when I'm doing the derivative, I'm going to take the chain rule to figure out the derivative of the bottom. So let's follow the quotient rule. So quotient rule goes derivative of the first times the original of the second, of the bottom, subtract the original of the top, derivative of the bottom. So derivative of the bottom in this case is a chain rule. So I'll bring my exponent down, original inside, reduce exponent by 1, and derivative of the inside, all over the bottom to the 1/2 squared. Now there is a lot of simplifying you can do on this case. I'll save that for another video. This is just following the quotient rule pattern. Okay, so here I have derivative of the top, original of the bottom, minus original of the top, derivative of the bottom, all over the bottom squared. And that gives you the quotient rule. Okay, thank you very much.